So if we start at 50 by 150 and decrease the length by 10 feet, what's the length going to be?
140.
Be 140 feet, right? Okay. Then we'll just emphasize keeping the perimeter unchanged, because some of you had dimensions that changed the perimeter. Okay? And that's not going to do me any good, because I don't want to change the perimeter. I don't want to increase it because the guy won't let me increase it. I don't want to decrease it because I'd be losing land. Okay, keeping the perimeter unchanged, we get width, what? We're keeping the same perimeter. We're decreasing the length by 10 feet. What do we have to do to the width?
Increase.
Have to increase it by 10 feet, or the perimeter would change, right? If I've got to walk 10 feet less each time I walk the length, going out and coming back, if I don't want that distance I walk to change, I'm going to have to increase the width by 10 feet. Common sense, but also fairly common sense on the concept of perimeter. Not written very well, but the area is 8,400. Not sure I made that 8 look any better. Square feet. That square looks pretty ambiguous too. Okay? I didn't realize I was going to have to write the conditions down again, so I didn't leave myself enough room to do that. But that's what we've got. Okay? Now, on to the first question. At what average rate, with respect to length, did the area change when the 150-foot length increased by 10 feet? And by average rate, I'm referring back to the average rate of change with respect to length. Average rate of change of area with respect to length. Okay? Got to understand, ways the wording can be rearranged. Well, what do we mean by the average rate of change of area with respect to length?
Length is X and area is Y.
What do we mean by this? We mean the change in area divided by the change in length. What's the change in the area? Sorry?
10.
No, that's a change in the length. What happened to the area when I increased the length by 10 feet?
Increased by 900.
Sorry?
Increased by 900.
Increased by 900? No, that's what happened when I decreased the length by 10 feet? It's okay. That was a good answer, but you had the wrong question.
Decreased by 1,100.
I'm sorry?
Decreased by 1,100.
Decreased by 1,100. Now let's be specific, because not everybody necessarily has made the mental jump. Okay? Area changed from 7,500 square feet here. When we increased the length by 10 feet, the area became 6,400 square feet. So what's a change in area? It's the area we ended up with minus the area we started with. It's negative 1,100 square feet. Okay? Now, just for future reference, because we're going to have to calculate it, okay, if we decrease the length by 10 feet, how much did the area change? Well, it started at what and ended at what?
Started at 50.
What area did we start with? What area did we start with?
7,500 square.
Yeah, the 50 by 150, which was our 75. That's our original area. That's our kind of starting point, okay? That makes sense? So the area was 7,500 square feet. What did the area become when we decreased the length by 10 feet and kept the perimeter the same?
8,400.
Sorry?
8,400.
8,400, yeah. 8,400 square feet. Right? So the change was what?
900.
900 square feet. Of course, Cody already said that. Okay, a little out of turn, but that was a good answer. This would have been a better one, but that wasn't bad. Okay. Make sense? So just putting this in context, in this case, when we increased the length by 10 feet, keeping the perimeter the same, our area went down 1,100 square feet, right? Okay? So that's our change in area, negative 1,100 square feet. That's our numerator. Okay? What's our denominator?
Change in length is 10 feet.
Yeah, it's our change in length, right? So our change in length is plus 10 feet. I don't have to actually calculate that because our premise was that we increased the length by 10 feet. That's a plus 10-foot change, right? Now I could take, 150 feet and subtract from 160 and get 10, but that would risk me having calculated the 160 correctly. It'd be more complicated, okay? Since I know the change was plus 10 feet, if I did the area correctly, which I kind of hope I did, it'd be embarrassing if I hadn't, if I did the area correctly for that situation, then I have all the numbers I need, right? Okay? So the average rate is negative 1,100 square feet over 10 feet, which is negative 110. Now I can divide feet into feet squared and get just feet, right? And algebraically that's what I would want to do. but really this means negative 110 square feet over feet, or negative 110 square feet per foot of length. Might be hard to read that. Negative 110 square feet per foot of length. So negative 110 feet squared per foot. That means square feet per foot. Square feet of what? Square feet of area per foot of length. Okay? See, probably need to think about that a little bit, but that's what it means. Now, I'm going to have to do a little kind of uneven board here, but it's not what we need, so I'm going to get it out of the way. Okay. Now another way of looking at that is if I've got length here and area here, this tells me if my length is 150, my area is, is we'll put 7,500 here, and we'll note that area is in square feet, length is in feet. So we have this point on the graph. Does that make sense? Doing area versus length. Okay. And if the length is 160, well, this isn't going to be a well-scaled graph. My origin would have to be much further to the left, but we can still visualize. Then I'm down to 6,400 square feet, so that would be a point right here. Okay? So on a graph of area versus length, we have the points 150, 7,500, and 160, 6,400. Well, take a minute, sketch me the fundamental triangle. Sketch me a fundamental triangle for these 2 points. All you got to do is slop down 2 points, call one of them this, one of them this. You don't even need a set of coordinate axes, so don't take the time and bother with it. Just take a triangle that looks like this, label this point 150, 7,500, label this point 160, 6,400, sketch and label your fundamental triangle.